quality of sound. The quality of sound, we might hear the word timbre. The timbre has to do with the sound that is characteristic of the instrument, okay? And what does that depend on? So when you hear an instrument being played, say you don't see it, but you just hear it, you can immediately identify, oh, this is a guitar, this is a flute, this is a piano, even if they're playing exactly the same frequency. So how does that happen? That is the process of timbre, okay, because they have different timbre, which means they have a different set of harmonics which are characteristic of that instrument. And your ear learns to recognize that. So if you just have the tuning fork, remember I told you that produce the most pure sound. So you can produce just one frequency, no higher overtones, no higher harmonics, just the fundamental. So we have all the intensity at just one first harmonic or the fundamental, okay? Next, if we look at a different instrument, say the flute, now it produces a more complex sound. So we don't have one pure note, we have a combination of notes. And you can see that now the note has got modified by superposition. And the superposition is of these harmonics. So the flute characteristically will produce a very large second harmonic, greater than even the first fundamental, and a big fourth harmonic. And so this will produce a characteristic sound, which we call the flute. Yeah? Similarly, if you go to another, and the clarinet will produce a different sound, and so on. Another aspect of the quality of sound is the pitch. Pitch has to do with frequency. So it's our human response to hearing a frequency, okay? So it's the psychological reaction that allows humans to place a sound on a scale. When you hear a note, if you are trained in music, you can say, oh, this I recognize, this is middle C, this is the A, and so on. So that reaction to hearing the frequency is called pitch, okay? And lastly, let me just say one more thing about the quality. One more thing that you should know is the intensity of sound that's related to the volume of the sound, yeah? Okay, so that's about the quality of sound. Now a little bit about the human ear. We don't need to do much of this in physics, but just to tie it in with the physiology and anatomy of how we actually hear sound. So this is the outer ear. We have three parts to our ear. We have an outer ear, which is the pinna, a middle ear, and an inner ear. The outer ear contains the spina. Its job is to just collect the sound. So it collects quite well from the front and the sides. If somebody is speaking behind you, like in a car, you often can't hear them too well. They have to speak louder than usual. And the sound from there is collected and it goes through an ear canal, okay, to three sets of bones which form the inner ear. So this and the inner canal, ear canal, together form the outer ear. Then there's the eardrum, yeah? And the eardrum begins to vibrate with the frequency that is picked up from the outside. That vibration is passed through the bones. These three bones are called hammer, anvil, and stirrup. Okay, up here, hammer, anvil, and stirrup. This is the middle ear, where the sound is amplified. Remember, sound travels better in solids, so the bones are solid, and the sound is transmitted to the inner ear as vibrations. The inner ear consists of this long spiral tube called the cochlear tube, or cochlea, okay? And the nerves are attached to that cochlea. So this tube contains a fluid that starts vibrating, and in the fluid there are lots of hairs which start vibrating. And that whole vibration pattern is sent through the nerves to the brain ultimately to interpret it. Yeah? So this is the structure of the ear. You just need to know the three portions of the ear and what they consist of. Okay? If you take a grandparent often for a hearing test, you will see these kind of curves. So we look at this graph. What's plotted against what? Here's intensity in decibels, which means how loud does a sound need to be before a person begins to hear it, versus the frequency. So we know we hear from 20 hertz to 20,000 hertz. Here we're just testing till 20,000 hertz. Yeah? And at each different frequency, you're going to increase the intensity till the person begins to hear. Yeah. Next frequency when they begin to hear, and so on. So you get these different curves, and at each curve, you will see that you have a dip here at about 3,300 hertz. We have a dip. That's the sound that's easiest for us to hear. Yeah? So these are actually normal. This is a normal frequency response curve. Some people, as they get older, maybe they can't hear very high frequencies or very low frequencies. And then you see distortions in this kind of graph. But I just wanted to show you a typical one. Okay, thank you.